On further consideration, what I've decided to do is I'm going to do everything from this point forward with OSPF in the confines of the configuration. So first of all, we're going to build our topology. We're going to use the same deployment that we had when we were working with our EIGRP configuration. So bearing in mind, what we have is we have R1 connected to R2, connected to R3, connected to R4. We're sharing our links. The 0, links for the horizontals, and the 0, 1 interfaces for the verticals. Now, we still have those loopbacks. Remember, it's going to be the router at number 4 times. So 2.2.2.2, 1.1.1.1, 3.3.3.3, and 4.4.4.4. All right? So what we're going to do is let's run OSPF. Now, what I want to do is this. I am going to do some manipulation here, because what I want to do is I'm going to take R1 and R2 and I'm going to connect R1 and R2 such that they're going to be operating in OSPF, and the area that I want to be able to configure is going to be area 1. Now, I'm not going to have an area 0 yet, and we're going to learn that that's not going to impact everything, because as long as we only have one area, it doesn't matter, because we're not going to be traversing another area. Therefore, we have no requirement for area 0. So let's illustrate what's happening here. So on this device, all I'm going to do is I'm going to go to the appropriate interface on R1, and I'm going to do my configuration. But first, let's go ahead and create a routing process. Router OSPF 1. Now, I'm going to advertise on R1 the physical interface that I have shared with 10.1.12.2. So here I'm going to say network, and I'm going to say 10.1.12.1.0.0.0.0, and I want to place this in area 1. Now, what I'm going to do is I'm going to cut over to R2, and here I'm going to advertise the loopback interface as well as the physical interface that's on the FOO configuration. So let's do that again. Again in area 1. So I'm going to say router OSPF 1 network 10.1.12.2.0.0.0.0 area 1. And I'm hopefully going to be able to get a link. While I'm waiting for that, I'm going to go ahead and advertise my loopback. I'm going to say network 2.2.2.0.0.0.0 area 1. Do show IP protocols. Let's take a look at the output here. The show IP protocols is going to tell me information about my OSPF deployment. And notice it's telling me that I'm actually routing for networks 2.2.2.2 and 10.1.12.2, both in area 1. Now the other part of this is that I want to be able to verify the status of my neighbor relationship. So I'm going to come here and I'm going to actually execute a show IP OSPF neighbor. I need to use the do. And when we look at this, what we're going to see is the fact that this device has actually formed a neighbor relationship. And the neighbor relationship that it's formed has been with its neighbor 1.1.1.1. Notice that I have a full operation, and I'm paired with IP address 10.1.12.1. Now, when I look at this, on R2, if I do a do show IP route OSPF, what I'm going to find is I have no prefixes. Why? Because nothing's being advertised on R1. Now, if I go over to R1 and do that same command, do show IP route OSPF, I am going to see the 2.2.2 interface being advertised by R2. What I want to call your attention to is the fact that this prefix is being advertised as a /32. Now, if I take a look at the physical interface on R2, or the virtual interface, do show run interface LO0, what am I going to see here? It's actually a /24. Now what we need to understand here is this is the default behavior of OSPF. OSPF is always going to advertise loopback interfaces on or using a /32. It's going to advertise them as a host route. Let's take a look at that and look at it critically on R1, because what I want to do is I want to look at my OSPF database. Show IP OSPF database. the most handy command that you're ever going to implement or work with when it comes to working with OSPF. Notice here I have type 1 LSAs. Remember, we said they were called router link state LSAs, and our netlink state LSAs are our type 2 LSAs that are being generated by the idea of the DR. So let's look at this. So first, let's say that we need to find out information about our neighbor. So I'm going to say show IP OSPF neighbor, and one of the options that I'm going to be able to have here, excuse me, my system is kind of bogged down, is detail. Now notice here, this is going to give me information about the neighbor. So first of all, the DR is going to be the IP address 10.1.12.2. The BDR is 10.1.12.1. That's me. Also notice that in this configuration, I know I'm running in area 0. I have my IP address that is configured on my individual interface. And the other part of this is that I see information associated with my dead timer. And it even tells me how long my neighbor has been up and operational. Now what we've got here is a single area deployment of OSPF. Now, when we look at this, I'm going to take a look at my table even closer. So show IP OSPF database, and I want to look at my router LSAs, and I want to look at router LSAs that are being advertised by my neighbor 2.2.2.2. And what we're going to see here is it's actually advertising two links. It's advertising a stub network of 2.2.2.2, and it's describing a transit network of 10.1.12.2. So what this illustrates to me is the fact that the system is advertising that stub network as a loopback. Now, loopbacks are always going to be advertised as stub, therefore they're always going to be 32-bit unless we step in and manipulate that process. How do we do that? Well, we go to R2, where the prefix is being advertised. We go to the interface itself, and under the interface, I'm going to say IP OSPF network, and I'm going to have the capability of specifying a network type. I'm going to say point to point. Now, the moment I do that, when I come back over here and go to R1, and repeat this command, show IP OSPF database advertising router 2.2.2.2, and hit enter, notice now what's happening is it's still classified as a stub network because it's not going anywhere. But notice what's happening here is my network is going to be the native mask, 255.255.255.0. So it's a /24-bit mask. Now, we also can look at the routing table, show IP route OSPF, and see what it tells me, and it's going to tell me I'm learning this, and now it's got the proper mask on it. Now, looking at this, we have an O route. O routes means internal prefixes. So these are internal OSPF prefixes that are known inside my area. Now, notice we only have area 1. What I'm going to do is, just for the sake of argument, I'm going to now expand our topology into an actual multi-area OSPF deployment. What I'm going to do is I'm going to take R1 and R3, and I'm going to run OSPF such that R3 is advertising its physical interface as well as its loopback into area 2. Say area 2. All right, let's make that happen. So all I'm going to do is I'm going to come over first. I'll start on R1 and advertise the other link. So I'm going to say config T. I'm going to say router OSPF 1. I'm going to advertise the network of 10, 1, 13, 0, 0, 0, 0, 0, area, and I said I wanted to do it in area 2. Now, I'm not advertising this network. I keep saying that, and it's not the proper term. What I'm saying is that whatever interface that has this address with this mask, which means it has to match exactly, is going to suddenly start participating in OSPF. It's going to be advertising the IP address on the network, it's going to be advertising the network of its basic configuration. So it's going to advertise that particular link. Now let's go over to R3 and do the marrying configuration. Router OSPF 1 network 10.1.13.3.0.0.0 area. We said it would be area 2. Did I mess that up? No. So notice I have my link went from loading to full on my basic operation, which actually you can't see very well because I'm in the way. Notice that black highlight, loading to full. So that link has now come up. Now what I want to do is I also want to advertise my loopback. So I'm going to say network 3.3.3, match it exactly using a wildcard mask, and I'm going to advertise it into area 2. Now what I should be able to find is when I go over to R1, I should be able to see the prefixes that are being advertised to me. Show IP route OSPF. Now looking at this, I see 2.2.2, I see 3.3.3, it's being advertised as a /32. Just for the sake of follow through, I'm going to go ahead and change that. I'm going to come in here and say interface LO0 IP OSPF network point to point. Cut back over to R1 and execute that command, and we should see ultimately that these prefixes will end up with their actual native masks. It's not necessarily important that you do this in a live environment, but Cisco may ask you to be able to demonstrate the fact that you understand that loopbacks are always going to be advertised as host routes /32s. And in order to be able to change that behavior, I just want to make certain that we drive that point home. Again, it's not necessarily in a live environment, but we're using loopbacks to simulate networks in our topology right now. So from this device, can I ping 2.2.2.2? Can I ping 3.3.3.3? Yes, I can. Now looking at this, what we see is our system is going to have those connections. And I actually lost my pen. Bear with me just one moment while I bring my pen back up. So our topology, like I said, was R1, R2, R3, and R4. Right now here, on these links here, we're running OSPF area 1, and here what we did is we went ahead and configured OSPF area 2. Now we're not finished with it yet, I don't think. Yeah, we actually are. But the point here is if I go over to R2, what reachability information am I going to have in my routing table? Let's do that. Let's cut over and see what happens on R2. So now what I'm going to do is I'm going to say in, and I'm going to say show IP OSPF, or show IP route OSPF. And let's see what I see. Notice I'm not learning any prefixes whatsoever. R1's not advertising anything. That's well and good. But notice I'm not learning anything from area 2. And the rationale behind this is that the router between area 1 and area 2 is not considered to be an area border router. It's not considered to be an area border router because it is not either physically or logically attached to area 0. Let's look at that particular situation here. What I'm going to do is I'm going to say show IP OSPF, and I want to look at the output of the border routers command. Notice I have no border routers. There's nothing in this output. Now the moment I go over here to R1 and I take and create a loopback, let's say I didn't advertise 1.1.1 into the process. So what I'll do is I'm going to use 1.1.1 and I'm going to say I want to advertise it in area 0. So I'm going to go router OSPF1, and I'm going to say network 1.1.1.1 0.0.0.0 area 0. And the moment that I do that, now what I'm going to find over here on R2 is that it's going to recognize that device as being an area border router. And see, here it is. It's saying the router 1.1.1.1 is actually an area border router. It's done 5 shortest path calculations, and I've learned about it through area 1. So now when I come up here and I do my show IP OSPF network command, or my show IP route OSPF command, what I'm going to see is now I have the prefixes that I'm looking for. And the way I learn these prefixes is because I now have type 3 LSA, show IP OSPF database. And let's look at these. I now have the summary link LSAs that are being advertised. These are my type 3s. So here's my type 1s, here's my type 2s, here are my type 3s. And notice that they're all being advertised to me by my area border router, R1. So now if I go through and repeat that process, I can now ping 1.1.1.1 because I'm learning about it because it's an area border router that's advertising, and I can also ping 3.3.3.3. So we have full reachability in our infrastructure because when we look at how this is being deployed, the implementation directly relates to how we have the configs. We've walked through our different verification processes, and we've walked through all of the fundamental elements, but I want to take this a little bit further. Let's take this off-road. Let's go ahead and look at this in the confines of how we would do OSPF in an environment whereby we're going to have an autonomous system. So, in the confines of an autonomous system, I said if I want to be able to generate external prefixes, I'm going to have routes that are going to be redistributed into the system. So where can I really readily do redistribution? Well, first of all, what I want to do is I'm going to come up here and I'm going to create an expanded topology. And what I'm going to do is I'm going to say, I want to create an interface or area on R4 and R3, and I'm going to go ahead and say that this is going to be in AS200. So 200. All right, so let's go ahead and get that implemented. So take myself off the equation, and I'm going to grab my gear. I'm going to go to R3, and I'm going to need to make the matching config. But in this instance, I don't want to use the network command. I'm going to use the IPOSPF command under the interface. That's always interesting. So what we'll do is I'm going to come under here and I'm going to go interface E00. I'm going to say IPOSPF1 area 200. And I'm going to advertise that now. So now if I come in and say do show IPOSPF interface brief, what I'm going to see is now this interface 00 is now participating in area 200. Let's go to R4 and do the marrying config. Config T, router, OSPF 1. I'm going to say network 10.1.34.40000 area 200. Network 4.4.4 0000 area 200. Do show IP OSPF neighbors, and it's going to tell me how I'm configuring. Notice now I'm in two-way. Let's see what happens if I can catch it in another configuration. Two-way, it's really hard to catch it because by the time you actually sync on it, it's moved from two-way to exchange. Exchange start, remember, is where we're going to be exchanging the DBDs. The moment we exchange DBDs and we're going to be sending those link state updates, then we're going to be in the exchange state where we're actually exchanging updates. Then after that we move from loading to full once we've got everything in place. All I got to do is just basically wait for this, and like I said, I'm very, very impatient. R3 has finally come up, it's operational, and went from loading to full. So now let's take a look at our configuration here. On R4, what I want to do is I'm going to do show IP OSPF neighbors. I've got my peering, show IP route, and I want to look specifically at OSPF. Notice I'm learning no prefixes. The reason I'm not learning any prefixes is R3 is not advertising anything into autonomous or into area 200, and I am not logically connected to area 0 or physically connected to area 0. The point here is the fact that when I have area 200 in my topology, what's happening is 200 is connected to 2, 2 is connected to area 0, but we do not have a direct connection between 200 to area 0. Now there's going to be a way for me to overcome this, but what I want to do is I want to first look at my show IP OSPF database command. And what we're going to see here is I have type 1s, and I have type 2s, I have no type 3s. The reason being is when I come up here and say show IP OSPF border router, I don't see any information. So there is no ABR in this infrastructure. Why? Because when we look at R3, R3 has no physical interfaces or logical interfaces that exist in area 0. Now there's two ways that we can fix this problem. One of them would be that I can logically connect it to area 0, and that's what I'm going to do. So feasibly, here's what I'm going to do. I'm going to do a configuration on R1 and R3 such that I'm going to build something called a virtual link. A virtual link is going to give me a logical connectivity to area 0. So the net effect is I'm going to pick an area that I'm going to use to reach into and grab area 0 and pull it down to me. So the idea here is that I'm not moving myself closer to area 0. I'm pulling area 0 through another area such that it's going to be logically adjacent to my device. So let's take a look at exactly what's involved in this process. So the moment I want to do this, I need to first of all recognize what my neighbor relationships are. Do show IP OSPF neighbors. I'm paired with 2.2.2 and 3.3.3. So what I'm going to do is I'm going to go router OSPF1, and I'm going to specify that I want to use area 2 to extend a virtual link to the address of 3.3.3.3. So that's R3. Now I'm going to start getting messages, error messages on R3 that's going to let me know that I have a possible problem sometimes, and they may be delayed. Let's see what's going on here. So area 2, make sure that's right, area 1 to R3, 3.3.3. Here's area 3. No messages. That's all right. What I'm going to say now is router OSPF1, and I'm going to say area 2, extend a virtual link to the address of 1.1.1.1. Do show IP OSPF neighbors. Now before I could execute the command, we see that the OSPF virtual link 0 went from loading to full. Now the moment that this has happened, what ends up happening now is I should have reachability on R4. Let's go to R4. Show IP OSPF, or show IP route OSPF. Now looking at this, now notice I have all of my information. I have reachability to R2, ping 2.2.2.2. I can even source it off of my own loopback 0. Whoop, loopback 0, not loopback 9. And I have full reachability. I also, when I look at my information in my show IP OSPF database, I'm going to see that I have type 3 LSAs, but I'm also going to see something that's pretty interesting. In the confines of this device, I have type 3 LSAs. Now what I want to do is I want to come over here to R3 and execute that same command. Exit, show IP OSPF database. Now notice I have everything in here, but what I want to call your attention to is that we have this DNA. That does not stand for deoxyribonucleic acid. It stands for do not age. Because the virtual link that we used to get this peering up and operational, that pulled the control plane configuration such that R3 is going to be logically adjacent to area 0, is going to be an on-demand circuit, which means it's not going to get reset by the system. Let's take a look at that. I want to look at the nature of that configuration. Now, I already did the show IP OSPF neighbor command. The show IP OSPF neighbor command gives me a little bit of information about the virtual link, but what I'm going to do is I'm going to say show IP OSPF virtual link. And what that's going to do is it's going to give me all the details about my virtual link. My virtual link is going to be connected, or is connected, to 1.1.1.1. Notice it's saying do not age LSAs allowed. Why? Because this is being run as a demand circuit. So in other words, it's not going to be brought down. It even comes up and tells me the nature of my connectivity, which is going to be point to point. Now, these are all valuable points. These are all ways that we can actually repair issues in our infrastructure. Now, another way that we could look at this also is we've seen our routing table. Let's take a look at it just one more time. Show IP route OSPF. What we see are O routes, which are internal prefixes that we learned from type 1 LSAs and type 2 LSAs. We have OIA routes, which are going to be prefixes that we learned from the area border routers because they're generating those type 3 summaries. So these the OSPF inter-area prefixes are going to be prefixes that we're going to be learning between areas by virtue of the fact that the ABR is going to be generating type 3 LSAs. Now, when we start really stepping into this and looking at it, what I want to do is I want to go one step further, and we're going to go over to R4 and we're going to redistribute a prefix. So the idea is that if I come over to R4, config T, do show IP, interface brief, E, assigned addresses, what am I going to find? Well, I'm going to find the fact that I have a loopback, but I'm already advertising it. So what I want to do is I'm going to create a new loopback. I'm going to say interface LO 100 with an IP address of 44, 44, 44, 44, 255, 255, 2550. IP OSPF1 area. And what I'm going to do, actually, I'm not going to advertise it into an area. I said I was going to redistribute it. So what I'm going to do is I'm going to go to my routing process. So I'm going to say router OSPF1, and I'm going to say redistribute connected interfaces. But what I'm going to do is I'm going to say I want to use a route map. I'm going to call this route map connected to OSPF. But I only want to send one prefix. I don't want to send every connected interface into OSPF. So what I'm going to do is I'm going to create this route map. So I'm going to say route map or route dash map. I'm going to give it its name, connected to OSPF. And I'm going to say permit 10. I'm going to match interface loopback 100. So now what's happening is I should only be advertising the connected interface that is interface loopback 100. To verify this, I'm going to go ahead and create a new interface. I'm going to create interface loopback 01, and I'm going to say that that address is going to be IP address 14, let's see, we'll say 104, 104, 104, 104, 255, 255, 2550. Now let's look and see exactly what's happening. I'm going to go all the way up to R2. R2 is going to be the furthest end on my link. And let's see what we see. Show IP route OSPF. We should see an external prefix, and we do. That's what this stands for. E stands for external prefix. Notice in OSPF we have the same administrative distances for internals and inter areas as well as we have for our external redistributed prefixes. Now, do I have the capability of reaching this? Ping 44, 44, 44, 44. And I do. I can even source it from my own loopback address. So again, we've got reachability in the infrastructure, but how did we learn that prefix? Well, we learned that prefix because of Type 5 LSAs, and we also needed to have the reachability information to reach the ASBR that advertised the Type 5. Let's take a look at that. So show IP OSPF database, and what we're going to see here is that we have our Type 5 LSA. The Type 5 LSA gives me information about the link ID 44.44.44.0, and the information is going to be relevant. So let's take a look at this. I want to say show IP OSPF database, and I want to look specifically at the ASBR summary LSA, which is the Type 5 LSA that's being advertised by router 4.4.4.4. We're going to hit enter. Now notice here, it doesn't give me too much information. So I'm going to take the advertised router command off, and I just want to look at the ASBR summary. Now notice this is giving me information. Now one of the reasons that it did not give me the information is I specified that I want to learn it from 4.4.4, and there was nothing in my table that corresponded to 4.4.4. Even though it says here the advertising router was the advertising device, which is going to be R4. Well, the problem here is that I need to look at this, and this is actually being advertised by 1.1.1. So it's R1 that's generating this Type 5 LSA and sending it to me. And it describes the criteria here of the actual R4 device, which is the ASBR. Now, when we look at how this is configured, what I need to do now is I need to resolve the identity of how to reach to 4.4.4. And in order to be able to do that, what I'm going to do is I'm going to look specifically at my database here. So actually I did this reverse. So ASBR, this is the information that's being sent to me. This is my Type 4 LSA, not my Type 5. I apologize. And when I want to look at the information with regard to my Type 5 LSA, what I would end up doing is I would type external. So here's my Type 5 LSA. My Type 5 LSA says, okay, to reach this network, this is the device that advertises it. But can I come up here and say, show IP OSPF database, and look specifically for anything in my database for 4.4.4.4? Hold on, IP OSPF database. Let's look for a router LSA for 4.4.4. Well, I don't have one. So 4.4.4.4. What about a type 2 LSA? So let's look at our network for 4.4.4.4. Don't have anything. What about a type 3 LSA? Summary 4.4.4.4. I actually have one. So in this scenario, what we know is that in order to be able to reach 4.4.4, I need to send my information to R1. So this is going to explain how we have all of our interconnectivity in the confines of OSPF operating and working in a multi-area environment. We've addressed the idea of virtual links. We even did redistribution, which is outside the scope of the CCNA. Now, when we start looking at how we're going to implement this, there's another way that we need to realize that we can manipulate LSAs, and that's going to be on the category or on the idea of filtering. Now, if I want to filter an LSA, what I actually am going to end up doing is that I'm going to designate a value with regard to a stub interface. Again, it's not part of the CCNA, but it's still something that you guys should be aware of. If I want to do a filter whereby I stop type 5 LSAs, I just create a stub area. If I want to do a filter where I stop type 5s, type 4s, and type 3s, I do a stub area with a no summary that's going to be identified by Cisco as a totally stubby area. Now the issue here is that the assumption is that I can't have a stubby area because I can't have type 5s, which means if I can't have type 5s, I can't do redistribution in an area. We need to recognize the fact that there is a type 7 LSA that's referred to as an NSSA LSA, which means it's going to define something called a not so stubby area. Don't want to really get you guys confused with it, but it is important that we point all of this out because it might not be part of the exam, but right now we've gone so far into OSPF, bringing up our connections, looking at the show commands, even demonstrating some concepts that we might use for troubleshooting, and it's all going to basically make it real. So right now, may as well just use the opportunity to, at the very minimum, introduce the concepts. And with that, I'm going to close this lesson. I'll see you guys in the next one. Bye-bye.